Hello everyone, and welcome to our contemporary math notes for section 1210. Today we're talking about solving probability problems using combinations. So if we know how to find combinations, then we can use these to solve our probability problems. So we're just going to go back and talk about, generally speaking, what does probability mean? Well, the probability of an event is the number of outcomes favorable to the event divided by the number of total possible outcomes. So this basic formula for probability never changes, and it doesn't matter what type of probability you're doing. So it's always the number of E over your total number. So we're going to go through an example now showing how we can use combinations to help us solve some probability problems. So in example 1, it says find the probability of selecting two picture cards when two cards are selected without replacement from a deck of 52 cards. So we can already do this using the AND formula. So remember, the probability of event A and event B is the probability of A times the probability of B. So what we're trying to do is find the probability of getting two picture cards. And so what we're going to do is find the probability that the first one is a picture card times the probability that the second one is a picture card. Okay, now this is done without replacement. So the first one, we have a 12 in 52 chance. And since we assume we got one of the picture cards, now we're down to an 11 in 51 chance of getting a second picture card. And this ends up being 11 over 221, which is about 5%. Okay, so that's how we use the AND formula when we have two events happening simultaneously. What we're going to do now is use our combinations to find the probability. So the first thing we want to do is find the number of ways in which two picture cards can be selected out of the 12 picture cards in a deck. Okay, well that's going to be 12 C2. So this right here is our 12 picture cards. And this right here is how many we want. Okay, so this is going to give us all the combinations of getting these two picture cards. And so here we have 12 times 11 over 2 times 1. Okay, and that's 6. And so we get 66 ways of getting two picture cards. Now what we're going to do is find the number of ways in which two cards can be selected from the deck of 52 cards. So now we have 52 cards, and we're selecting two of them. So this is the total amount of cards, and this is how many we choose. Okay, so 52 C2 will be 52 times 51 over 2 times 1. And this ends up being 1,326. Okay, so now we want to find the probability by dividing the number of ways you can get two picture cards by the number of ways you can get two cards. So you'll remember that the probability of any event is the number of the event over your total number. So what we're doing here is we're trying to find the probability of two picture cards. So what we're doing is finding the number of ways we can get two picture cards divided by the number of ways we can get any two cards. And so this is going to be 66 out of 1,326. And lo and behold, when we do this, we get 11 over 221, which is about 5%. You can see that that matched our original answer using the AND formula. Okay, so it may seem like we took longer to go through these three steps, but what we could have done right at the beginning is realized that this would be our formula, and the ways of getting two picture cards would have been 12C2, and the ways of getting any two cards would be 52C2. And then we could have gone straight to our answer of 5%. All right, let's move on. Example 2, a club consists of 4 men and 5 women. 3 members are to be selected at random to form a committee. So what is the probability that the committee will consist of 3 women? So here, we're looking for the probability of 3 women. And so what we want to do here is get the number of 3 women committees over the number of 3 person committees. Okay, so notice here that the women is going to be specific to the event, and the 3 is just going to be in general to anybody. Okay, so how many ways can we select 3 women from the entire club? Can we get 3 women out of the 5 women? So there are 5 women, and we want 3 of them to be in the committee. So 5C3 will give us the number of ways. Now dividing by, we're looking for a number of 3 person. So how many people are there? Well, if it consists of 4 men and 5 women, now we have a total of 9, and we're choosing 3. Okay, so again, all the information needs to be specific to women on the top, and then all the information on the bottom needs to be in general for all the people involved. Okay, and now we can just straight solve this, and you end up with 5 over 42, which is about 11.9%. All right, in number 3, an airplane has 10 empty seats left, 6 aisle seats and 4 window seats. If 3 people about to board the plane are given seat numbers at random, what is the probability that they are all given aisle seats? Okay, so what we're looking for here is the probability that they get 3 aisle seats. So it's going to be the number of ways we can get 3 aisle seats out of the 6 divided by the number of ways you can get 3 anywhere seats. Okay, so the number of 3 aisle seats out of 6. So that's going to be 6C3 divided by the number of 3 anywhere. Well, there's a total of 10 seats, and we're choosing 3 of them. Okay, so again, the 3 is going to be our R in both cases. And where this gets a little bit tricky is when you're dealing with aisle, you have to take the total number of aisle here, and then when you're dealing with anywhere, you take the total number of anywhere right here. All right, and when we solve this, we end up with 1 out of 6, which is about 16.7%. Okay, so I'm not going to spend a lot of time on how to actually calculate this. The biggest thing is if we can set it up, then the calculation is going to be easy. All right, let's move on. In example 4, you're dealt a flush in the game of poker when you're dealt 5 cards of the same suit. So if you're dealt a 5-card hand, find the probability that you'll be dealt a heart flush. So that's what we're looking for right there. So we want the probability of a heart flush. Okay, so basically we want the number of ways we can get 5 hearts divided by the number of ways we can get 5 cards. Okay, so let's set up our combinations now. So R has to be 5 for both of them. And basically we need to figure out, well, we're choosing out of the hearts, so how many hearts are there? Well, there's a total of 13 hearts. And then we're choosing out of cards, and we say, well, how many cards are there? Well, there's 52. So we get 13 C5 over 52 C5. And if we use a calculator, we end up with 33 out of 66,640, which is approximately 0.05%. So the chances of getting a heart flush when dealt 5 cards is very small. All right, let's move on. In example 5, the Kellogg Company is testing 12 new cereals for possible production. They're testing 3 oat cereals, 4 wheat cereals, and 5 rice cereals. If we assume that each of the 12 cereals has the same chance of being selected and 4 new cereals will be produced, let's find some probabilities. So 1, that no wheat cereals are selected. So we want the probability of no wheat. Okay, so we're choosing 4 cereals. So we want the number of ways we can get 4 non-wheat cereals. And we want to divide that by the way we can get the number of 4 any type of cereal. Okay, so when we set up our combinations, we have our R is going to be 4 because we're choosing 4. And how many non-wheat cereals are there? Well, the non-wheat cereals are going to be the 5 rice and the 3 oat. So there's a total of 8 non-wheat cereals. So that's 8C4. And then divided by any cereal, well, that would be 12. And when we calculate this out, we get 14 over 99, which is approximately 14.1%. All right, let's try letter B. Here we want the probability of at least 1 wheat cereal. So if we remember, the probability of at least 1 is always going to be 1 minus the probability of none. Okay, or no wheat cereals. So if we think about it, we already found the probability of no wheat cereals was 14.1%. So all we have to do in this case is 1 minus your 14.1, or in this case, 0.141. So if you want to do this, you can also think 100% minus 14.1%. Okay, either way, we end up with 85.9%. Okay, so watch out for little things like that when we're talking about at least 1. It's 1 minus the probability of none, and if we already knew the probability of none, then it's going to save us some time here. All right, and one final example. Here we want 2 wheat cereals and 2 rice cereals. So this one's a little bit different because we have 2 different types of cereals that we're looking for. So we want the probability of 2 wheat and 2 rice. So what we're going to do in this case is find the number of ways we can get 2 wheat cereals and multiply it by the number of ways we can get 2 rice cereals. So we use the fundamental counting principle because we're multiplying these together. Okay, and now we're going to divide it by the number of ways we can get for any type of cereal. Okay, so how can you get 2 wheat cereals out of 4 wheat cereals? So that's going to be 4C2. And we're going to multiply that by, well, how can we get 2 rice cereals out of the 5 rice cereals? That'll be 5C2. And then we're going to divide this by the number of ways we can get any 4 cereals. So that's going to be 12C4. Okay, now when you set up these problems with the fundamental counting principle, you have to make sure that the number that you're choosing on top adds up to be the number that you're choosing on the bottom. And you can also see here when you did wheat, we had 4 wheat cereals, and when you did rice, we had 5 rice cereals. Okay, and when you use your calculator and multiply this together, you're left with 4 out of 33, which is about 12.1%. All right, so that is how we can use combinations to solve our probability problems.